Hey, this is Group 3. I'm Qingtian Sun. I'm a third year PhD student in math. For this semester, I think I got used to coding with R and Python. So it's really helpful. Um, yeah, and it's been great to work with Jingwen.
Hi, this is Jingwen Sun. I'm a graduate student in applied financial mathematics. I have learned a little about the language R and MATLAB before, and after this class, I think I have a better understanding of Python, R, and MATLAB.
Okay, so this is our project. This is our group members. And okay, so this is our project objectives. So we first select some stocks which prices tend to rise in the short term, and then we use this uh, five stocks to construct a tendency portfolio and adjust daily. So this is our first portfolio, and then we apply the Fourier transformation to these stocks and build an option strategy based on these stocks. Okay, I'll be talking about the first two objectives. This is stock selection. Um, okay, so the method we use that we compare is this stock's first 10-day moving average with its previous 30-day moving average, and if this 10-day moving average is greater than the 30 days, then we pick this stock. Uh, this is when we actually do it. We use the pipeline function from Quantopian. Okay, this is the initialize function, and we call the pipeline function. Call once at the start of the algorithm and create our dynamic stock selector. Okay, so you can see this. Yeah, just as it looks, we select these stocks if this has a moving average, a 10-day moving average greater than the 30-day moving average. Okay, then we print out the results. So we select the first five stocks based on this um, information. Okay, and then after we found these five stocks we want, as shown here, this is the five stocks. Then we go to Yahoo as we did in the homeworks. We download its adjusted close price of these five stocks. Pick this to be the sample period from June 30th to October 30th. Okay, so after we got this close price for these five stocks, we try to build a tendency portfolio based on these stocks. The reason we do this is because the tendency portfolio seems to have the largest Sharpe ratio on efficient frontier. Okay, so this is the same, basically the same as what we did in the homework. So we construct this QP problem, and we call the solvers.copy in Python. Hold the denominator to 1 and try to minimize the denominator. Okay, so using this code, we can find the weights for these five stocks. Okay, so this is the result we found, and okay, so we can try to build a tendency portfolio using these weights, but we want to, because every day the stock changes, so we need to adjust daily in order to keep the weights to stay the same. So we use this. So we first define merit balance in Quantopian. Okay, so we for each stock we let it weights to be that constant weight, and then um, and then we record the profit of this portfolio at the end of each day, and then we adjust it daily so that the weight stays constant. Okay, so we use this merit verse function and this merit balance function. Okay, so this is about the tendency portfolio, and then we're going to talk about the Fourier transformation.
I'm going to introduce the last two objectives. First, the Fourier transformation. For every stock, we apply Fourier transformation and set the ones at high frequencies to 0. then use inverse Fourier transformation to get a clearer trend. Here is the X1 rack, and then first, let me introduce the option strategy. There are two strategies. The first is bull spread strategy, and the second is bear spread. Bull spread is a strategy which can profit when stock price rises. And we built the bull spread strategy using two options to get a positive profit. The profit of the bull spread strategy is K2 minus K1 when the price at the maturity is larger than K2, and the maturity price minus K1 when the maturity price is larger than K1 and smaller than K2, and the payoff is 0 when the maturity price is smaller than K1. And the profit is just the payoff minus the cost. Since we buy a C1 and sell a C2, we subtract C1 and add back C2. And here, before computing the option prices and the payoff of the strategy, we first compute the stock prices at maturity using binomial tree methods. The stock prices at maturity are the only prices that needed for calculating a European option. Here, we store all the prices at maturity in the matrix S. And then we compute the option values at maturity under different stock prices, and then calculate backward using conditional expectation to get the present value of the two call options. And for bull spread, we build it by call options. Here we calculate the payoff of the bull spread and discount it to today, then use normal distribution to simulate the average value. And the second strategy is bear spread, which can profit when stock price falls. We build the bear spread strategy using put options to get positive profit. And the payoff of the bear spread is K2 minus K1 when the maturity price is smaller than K1, and is K2 minus maturity price when it's between K1 and K2, and the payoff equals to 0 when the maturity price is larger than K2. The profit equals to payoff plus P1 minus P2 because we buy a P2 and sell a P1. Just similar to the bull spread strategy, here we use two put options and calculate backward using the conditional expectations. And also, we calculate the payoff of the bear spread. Then, here is when we use a Fourier trend. We build the option strategy based on the Fourier trend and set the threshold to decide whether to use a bull spread or to use a bear spread. We calculate the current return and the average return based on the Fourier trend, and the ratio equals to the current return divided by average return, and the threshold equal to 1 because if the ratio is larger than the threshold, which equals to 1, then we expect the stock price to rise. And in that case, we should build bull spread, or otherwise we will build a bear spread. Theoretically, our stocks should build bull spread since they are selected to have rising tendency. And here is our main function. We saved out the code that calculating the payoff and profit of the option strategy in two functions. Here is the BT bull spread function and the BT bear spread function. And the last parameter is equal to 0 if we use call options, and is equal to 1 if we use put options. So here we set the last parameter to 0 in the BT bull spread to calculate the payoff and profit of the bull spread strategy using options, and the last parameter equal to 1 in the BT bear spread to calculate the payoff and profit of the bear spread strategy using the put the put options. Here are our results. These are the tendency portfolio performance, and this is a comparison in different holding period. The first holding period is from January 1st to October 27. From this chart, we can see the return is only 4.9%, and we can see that the profit of this tendency portfolio sometimes fall below the zero line, indicates a poor performance. And the second chart is the profit of the tendency portfolio in the holding period from June 30 to October 13. It clearly performs better with a return of 13.7% and always has a positive profit in this period than the longer period. And because this period is just same as our sample period, and we also test the portfolio in a forward period from June 30 to December 2nd, which has a good performance with a return of 20.39%. And this is a result of the option strategy. As we can see from the result, all these 5 stocks build bull spread strategy, which is in line with our choice of stocks that have rising tendency in the first place. And all 5 strategy earn positive profit under the bull spread strategy. That's all. Thank you.
Okay, thank you.